then let's start ourselves off with a nice easy circuit, just to kind of get our brains going again and make sure we still remember how to do this. And if I go slow, it comes out halfway legible.
Overrated.
Alright. Alright, so here's our circuit. There's R1, R2, and R3. So let's make R1, let's make it 225 ohms. R2, we're going to be 325. And R3, I'm going to call that 500 ohms. And I'm going to start off with a total current of, we'll make it easy, 0.1 amps. Good so far?
Yep.
Alright. So the first thing I'm going to do is I'm going to start with this parallel piece right here. And I'm going to redraw that just as a simple little parallel circuit. There we go. And I'm going to label this one. I've got R2 and R3. So I want to figure out the resistance just for this parallel part. So I'm not going to call this R total. I'm going to call this R23 because those are the two resistors I'm using. So when I add those, I have to add them inversely. So that's 1 over R2 and 3, 1 over R2 plus 1 over R3. So 1 over R2 and 3 together. 1 over, let's see, R2 was 325. And I'm going to add that to 1 over 500. Now, if I do that math on the side, what do I get right there? 0.6444. Then if I take the inverse of both of those, then I wind up with, what's that resistance again?
196.
I have two 196s?
Dot 96, 96, 97.
Okay. So that's our combined resistance for those two, right? Ah, okay. So is this number off then?
Yeah, it is.
Oh, that's cool. I can press down harder, it gets bigger. Okay. Somebody, I probably could rephrase that, but I'm going to leave it alone. Somebody take the inverse of 196.9696. I can edit this video later,
It's,
thankfully.
Yeah, you being recorded right now?
0.0051.
10051. All right, that was good. That's fine. So we're good on getting that resistance because that's just adding them inversely. So I know that's my resistance for this little circuit right here. 190. So now I'm going to draw that other circuit, right? I'm going to represent these two right here just as one resistor in series with this R1. So I'm going to put that R1 in there. And now this one's going to be R2 and 3 put together. R1. R2 and 3. I know that's 190. I'm going to call it 197. R1 hasn't changed. That's still going to be 225, right?
Yep.
All right. Now all I do is I want to get that total resistance because now we are actually getting the total resistance, and it's just 225 and 197, right? So somebody do that math for me real quick.
421.96 or 422.
422. 422 looks good. So that's my total resistance. So I can take that back to this original circuit, and that's just going to be that 422. Now in this original circuit I now have two of the totals, right?
Right.
So I can calculate my voltage. And we can use good old E equals I times R. So that's an E total, I total, R total. And I don't know what that is, that's what I'm figuring out. That's 0.1 amps. That resistance is 422. So I'll wind up with a nice easy voltage of 42.2, right?
Yep.
And that's in volts. So now that's my total voltage, 42.2. So I've got all my totals now for that original circuit. So now I'm getting somewhere, right? What's the next thing I'm going to want to do?
Find E1.
You want to get your,
Right, I can go back down to this series circuit right here, right? This one right there. So, because I know what happens to voltage in a series circuit, it's going to be additive, right? So I know what my total voltage in there is. I don't know what my voltage drop across this resistor or this resistor is yet. But what I do know is that current's constant, right? So whatever current I have coming into R1 is going to go through R2 and 3 together. And that's still going to be that 0.1. So I can figure out my voltage drop across R1. And that's what I'm trying to figure out. My current's just going to be 0.1 amps. R1 I know is 225. So I know my voltage drop across R1 is going to be 22.5, right?
yep.
That one's pretty easy. Now I can also figure out the voltage drop across both these resistors together, right? Now of course I can do it a couple different ways, but I'm just going to do it this way. So I2 and 3, R2 and 3. So the voltage is what I'm trying to figure out. I know that current's still 0.1, and I'll multiply that by, I'm going to say 197 to make it a little easier on ourselves today.
19.7.
Yep, and that'll be 19.7 volts. Now I can look at these two voltages to make sure they look like they're going to add up to my total voltage, which was 42.2. And yeah, I look good. That's pretty close because I know I rounded some stuff, so I'm all right. So I'm going to come back over here, and I know that was 22.5. Now what's nice is I didn't change anything to R1 here in this circuit, so I can take that value and put it right back up on my original schematic, my original circuit there to fill in that value. And of course, I already know I because this is still series at this point, so it's still just 0.1 amps. Figuring out power is easy because everybody likes pi. So we'll skip on to that parallel part. And if I can get there. Yep, there we go. All right. Now, we're going to come back to this parallel circuit here. We know R23 was 197, so that was the total resistance for this whole parallel part. I know my voltage was just the thing I erased a couple seconds ago,
19.7.
which was 19.7. So I know that's going to be kind of like my total voltage here for just this parallel circuit. So if I know voltage is going to be constant, and I know what my resistance is for both these resistors, I can start getting my currents through each one. So I'm going to call this E at R2 is going to be I2, R2, because I'm solving for the current because that's what's going to change in parallel. So I know 19.7 is going to be some kind of current times 325.
Yep.
So if I divide that on both sides, what do I wind up for a current?
0.06.
0.06? Anybody confirm that? All right, good. So that's my current for R2, right? And of course I can do the exact same thing for R3. There we go. So I know that's still the same voltage because that's in parallel, and current's what I'm solving for, and that resistance was 500. So what's 19.7 divided by 500?
0.0394.
0.0394. Now I have to make sure if I add these two together, they look like they come up to, add up to that total current I have coming in, which was 0.1, right?